So this is question number 13 of my school's mathematics examination for year 10. It says, what is the arc length of a circle that sustains 2.5 radians at the center when the radius of the circle is 8 centimeters? First of all, what is the formula for the length of an arc? Formula for the length of an arc is equal to theta over 360 times 2 pi r. But take note, this theta is in degrees, right? And from this question, they gave us our theta to be in radian. Just like the previous question we saw, question number 11 or so. We just need to convert these to degrees, right? So converting that angles to degrees, we have that. Let's change this to improper fraction. That will give us 5 over 2 radian, right? 5 over 2 radian, right? But recall that 1 radian is equals to what? 1 radian is equals to 180 degrees over pi, right? Yes, 180 degrees over pi. So if 1 radian is equals to 180 degrees over pi, what will be 5 over 2 radian? So therefore, 5 over 2 rad will be equals to 5 over 2 times 180 over pi, right? 2 here is 1, 2 here is what? 90. 5 times 90 will give me 450 over pi. That is the value of my degrees, of my angle in degrees, 550 degrees over pi. So I'll replace this theta now with this. So let's solve the equation for the arc length. So L is equals to theta over 360. So theta now is now 450 degrees over pi times over 360. That's 1 over 360, right? They are the same thing. So times 2 times pi times r. They gave us the radius of the circle to be 8. Right? Now we can start breaking down. Okay? 0 can cancel 0. Right? 9 here will give me 5. 9 here will give me 4. 4 here will give me 1. 4 here will give me 2. Pi will cancel pi. So my arc length, I'll be left with 5 times 1 times 2 times 2. 5 times 1 is 5, 5 times 2 is 10, and 10 times 2 is 20. So therefore, the length of the arc is 20, the unit is centimeter, right? Centimeter. That is the value of the length of the arc for this particular question, 20 centimeter. Let's move over to question number 14.